All right. Hello, everybody. So what we're going to do is we're going to talk about triangle congruence. But before we start anything with triangles, we have to make sure we understand some really key vocabulary that we're going to use and we're going to see throughout this. Okay, so first word we need to talk about is what a midpoint is. It's a word we're going to hear a lot. Okay? So a midpoint is something that divides a line into equal segments. Like this line, this is the midpoint here of the line A, B. M is the midpoint, which means it's divided equally in the center. Now, another word we're going to hear a lot is bisector. Okay? So lines can be bisected or angles can be bisected. So we can have what's called an angle bisector. Or we could also have a bisecting lines. So an angle bisector would be something like this. You got an angle right here. Okay, we're going to denote it A, B, and C. And the line BF bisects the angle ABC. What does that mean? That means it cuts it into two equal pieces. You could also have lines that bisect each other, like the line AB. Instead of having a midpoint, it can be bisected by another line into two equal pieces. So like by line, for example, CD. Bisected this in half into these two congruent sections. Okay, so something we've talked about before, but we really haven't given it key and explicit word. It's called when two triangles share a side. We talked about how they're sharing it, so they have the same exact side here. Okay, it's like this side here is in between these two triangles. We refer to that as the reflexive property. That means that we are both sharing use of the side. And there's one more very important phrase that we need to be aware of. It's called vertical angles. When two lines intersect each other, they create two sets of vertical angles, which means that these two pairs of vertical angles, like this pair of angles, is congruent to this pair of angles. They're called vertical angles. When two lines intersect each other, we've created two opposite sets of congruent angles. So those words are going to become really important as we're trying to work through creating proofs, but I just want to make sure we're on the same page as far as the language. Okay, so now we're going to try to connect this idea of proofs to something we've covered before. So we're going to talk about congruent triangles. This is something we've seen before. Got markings on the different sides. So that means I'm going to try to mark things. The first thing I talked about is I want to use colors to help me connect the notation more easily. So I have, these are two half circles, and these are two half circles, okay. This is one tick mark, and then this is three half circles. That's three half circles. All right, so we're going to connect these congruent pieces. So what we first have is angle IDL. Remember, order matters in terms of the letters. So going from the empty corner with no markings to the triple half circles, to the double half circles. So I have to do the same kind of order when I'm marking the angles on the other one. So U, C, E. Would be this angle here. And then next, I have side E, C is congruent, so double to triple, L, D. And then last, angle DLI is congruent to triple, double, angle C, E, U. All right, so now we've got these three sets. This is an angle, this is a side, and this is an angle. So remembering what we talked about before, this is one of the shortcuts that satisfies triangle congruence. So I have to prove every different part being congruent. We know that we have an angle, a side, and an angle congruent. Therefore, the two triangles themselves are congruent. So triangle U, E, C is congruent to triangle I, L, D. Why? Because of the ASA triangle congruency theorem. So this is what we've talked about before as far as proofs go. We're going to try to take this and formalize it now. There are three specific ways we formally write proofs. So I'm going to walk through on this specific example all three ways, just so that way you can see it with one example and see different connections. And then I'll do a couple more examples and flip back and forth between different representations of this formalization. So the first one is called the paragraph proof. What all that means is I'm taking this information and I'm putting it into a paragraph. So first thing I said is that the angle IDL is congruent to angle UCE. Angle or side EC is congruent to side LD, and then angle DLI is congruent to angle CEU. Okay? This information proves that the two triangles are congruent by the ASA triangle congruency theorem. So that means triangle UEC is congruent to triangle ILD. And there we have it. Okay, now we're going to talk about the next format. This is called the flowchart proof. It just connects the different pieces to make sure we're flowing in a continuous fashion. We're connecting how things get from one place to the other. So, first thing we had was IDL is congruent to angle UCE from our original picture. And that piece, we also had EC is congruent to LD. And then angle DLI is congruent to angle CEU. So these connect to the triangle UEC being congruent to triangle ILD because of, well, I'm using different color to make sure it's clear. ASA. Again, this is referred to as the flow chart proof. Okay? We have one more we need to look at. Next proof is referred to as the two-column proof. Okay? So it just means we're organizing into the statements and reasons. Okay? So we'll get more detail on how to label different parts of it. But ideally, to connect from the flowchart proof, the statements are the congruent statements, and the reasons were why those different parts are congruent. So for example, in this picture above, all these different pieces have already been pre-marked. That means they were already given to us. So we would say that they are given. So step 1, angle IDL was congruent to angle UCE. Step 2, side EC is congruent to side LD. This has also been given based on the notation in the picture. Next, angle DLI is congruent to angle CEU. That is also given in the picture. And then we know our last step here is that there's two triangles congruent. And that is because of the angle side angle congruency theorem. So now we're going to work through a few examples, focusing each time on a different type of proof. So here we're going to focus on the paragraph proof. Okay? So I'm going to go through the different pieces that I have and just kind of explain it. So I have angle DGO is congruent to angle CTA. Angle GOD is congruent to angle TAC. And then side OD is congruent to side AC. So I've got the different key pieces that I pointed out here. Well, I know from this, just to try to connect my different pieces here, I got my sides. This angle, and then this angle. So if I'm looking at my shape here, I can mark A, S, and A, S, which tells me that the triangle GDO is congruent to triangle TCA because of the AAS triangle congruency theorem. Boom. So now we're going to work on the flowchart proof. So the flowchart proof, we're going to make a little bit more specific and more detailed than the first example we looked at to try to make it very specific for you. First thing I need to do is I need to notate the things that I see here, okay? So it'd be nice if we could flip it around so it's the right direction. Perfect. Now we can actually read it. So we got a lot of different information here. So first I got angle ENW is congruent to angle TOW. That's this angle here. How do I know that those two angles are congruent? Well, the reason why I'm able to identify those two angles are congruent based on the fact that they are given. Okay? Now, the next thing I have here is side NW is congruent to side OW. This is also true because they are given. Now there's another piece of information in here. It's not as obvious because it involves one of the key definitions and phrases and terms I mentioned at the beginning of the video. That is this angle here. And this angle there. These two angles are congruent. So while I'm writing them down, think about why they might be congruent. So you got angle NWE is congruent to angle OWT. Why are these two angles congruent? It's because they are vertical angles. So these three pieces help show me that the triangle NWE is congruent to triangle OWT, because of angle, side, angle, triangle, congruence. Boom. All of these three pieces flow into that. Perfect. Our last type of proof is the two-column proof. I'm going to focus on things that I see. Okay, so statement, reason. First thing I see is that side, HP, is congruent to side, XP. That's because it's given. I see it on there on the diagram. It's given to me. Second thing. H side HN is congruent to side XN. That is also given to me based on the diagram. There's another piece of information, though, that's in here that is not as obvious. It looks like they're sharing a side. So that means PN is congruent to PN because it's being shared by both triangles. I'm going to use a triple to show that. Remember what that's called? Well, that is called the reflexive property. And last but not least, triangle PHN is congruent to triangle PXN because of SSS triangle congruence. And there you have it.